If you take a look at 1.1.1, the equation is already factorized. We just need to equate to 0. So we're going to have 3x minus 6 being equals to 0, or x plus 2 being equals to 0. We're going to have 3x is equals to 6. We divide both sides by 3. We get x is equals to 2. And if x plus 2 is equals to 0, then x needs to be equals to minus 2. So these are our two answers. X is equals to 2 or x is equals to minus 2. When the equation is already factorized, you don't multiply out like I see some people do. Right. 1.1.2. We're supposed to solve for 2x squared minus 6x plus 1 correct to 2 decimal places. That just tells us that we need to use the quadratic formula. We're going to have x being equals to minus b plus or minus the square root of b squared minus 4ac. Everything divided by 2a. This is the value of a. Minus 6 is b and 1 is c. If we substitute, we're going to have x being equals to minus multiplied by minus 6 plus or minus the square root of b squared. B is minus 6, so we're going to have minus 6 squared minus 4 multiplied by a, which is 2, multiplied by c, which is 1. Everything divided by 2a. So the value of a is 2. So we just have something like that. X will be equals to 2.82, or x will be equals to 0.18. These are the values of x correct to 2 decimal places. Quite an easy one. We just substituting in the quadratic formula. Let's take a look at 1.1.3. So in 1.1.3, we have x squared minus 90 being greater than x. Let's take x to the left hand side. We're going to have x squared minus x minus 90 being greater than 0. At this point, what you want to do is to find your critical values. How do we do that? We let x squared minus x minus 90 be equals to 0. Now we just need to factorize this. In factorizing this, we are looking for two numbers that when we multiply, we get minus 90, and when we add, we get minus 1. That is plus 9 and minus 10 being equals to 0. So x is equals to minus 9 or x is equals to 10. These are our two critical values. There's one thing we need to figure out. Our critical values is minus 9 and 10. We need to see if our answer lies between minus 9 and 10 or outside of that range. So let's go ahead and find out. What we can do, we can substitute 0 because it is a number between minus 9 and 10. If x squared minus 10 is greater than x is satisfied when we substitute 0. That means that all our answers lie between minus 9 and 10. But then if our equation is not satisfied, then it will tell us that our answer does not lie between minus 9 and 10. We need x to be less than 9 and x to be greater than 10. So let's go ahead and find out. X squared minus 90 being greater than x. Let's substitute 0. So we have 0 squared minus 90 being greater than 0. Minus 90 is greater than 0. Well, we can clearly see that this is not the case. Minus 90 is not greater than 0. So our answer does not lie between minus 9 and 10. Our inequality is not going to be satisfied. We're going to get an answer that is mathematically wrong, which will tell us that our answer does not lie between minus 9 and 10, but it actually lies outside. So what can we say? We can say that x is less than minus 9 or x is greater than 10. That is our final answer. 1.1.3. Let's take a look at 1.1.4, an interesting question. So we have x minus 7 square root of x being equals to minus 12. Well, I have square root of x, so I want to square both sides. But then if I have this x and I'm squaring both sides, it gets complicated. So let me take minus 7x to the right hand side and take minus 12 to the left hand side. I'm going to have x plus 12 being equals to 7 square root of x. Now I can go ahead and square on both sides. If I do that, x plus 12 squared, x multiplied by x, that is x squared, x multiplied by 12, that is 12, x multiplied by 2, that is 24x, plus 144 being equals to 49x. So now we need to take 49x to the left hand side. We're going to have x squared 24 minus 49, that will be minus 25x plus 144 being equals to 0. So now we just need to factorize this. We're asking ourselves the same question again. Which two numbers do we multiply and get 144? But when we add them, we get minus 25. That is minus 16 and minus 9. So we're going to have x minus 16, x minus 9 being equals to 0. So x is equals to 16 or x is equals to 9. Usually when you square both sides, one of your answers is not correct and you need to find that answer and cancel it out. But in our case, all our answers hold. But just be careful. Next time, when you're solving a problem and you end up squaring both sides and get rid of a square root, one of your answers may not be correct and you need to figure out which one is that one. Right, 1.2. Let's solve for x and y simultaneously. We have 2x minus y being equals to 2. I'm going to make y subject to the formula because it is less complicated. If I make x, I'm going to have to divide both sides by 2, which I don't want to do. So I'm going to have minus y being equals to 2 minus 2x. Divide both sides by minus 1. Y is equals to 2x minus 2. Well, I can call this equation 1, but I don't even have to do that. I can just solve it without calling anything equation 1. And then now we have x multiplied by y being equals to 4. In place of y, I can just substitute equation 1. So I'm going to have x multiplied by 2x minus 2 being equals to 4. X multiplied by 2x, that is 2x squared, and then minus 2x being equals to 4. Let's take 4 to the left hand side. We're going to have 2x squared minus 2x minus 4 being equals to 0. If we divide every term by 2, this is just x squared minus x minus 2 being equals to 0. Let's go ahead and factorize this. Two numbers that when we multiply, we get minus 2, and when we add, we get minus 1. So that is minus 2 and plus 1. X is equals to 2 or x is equals to minus 1. If x is equals to 2, what is the value of y? Let's find out. When x is equals to 2, y will be equals to 2. I'm substituting into this equation. Right. Y will be equals to 2 multiplied by 2 minus 2. Y will be equals to 2. Or y will be equals to 2 multiplied by minus 1 minus 2. So y will be equals to minus 4. 1.3. Let's take a look at 1.3. So in 1.3, we're supposed to show that 2 multiplied by 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2. It's even for all positive integer values of n. Alright, let's see how we can possibly show that. What I'm realizing here is that we have 5 to the n on this first term, we have 5 to the n on the second term, and we have 5 to the n on the last term. It seems like it would be a good idea to take 5 to the power n as a common factor. Let's go ahead and see how that will look like. This will be equals to 2 multiplied by 5 to the n minus 5 to the n plus 1. 5 to the n plus 1 is just 5 to the n multiplied by 5 to the 1. Because if you multiply these two numbers, you add the exponents and you get 5 to the n plus 1. Let's do the same for the last term. This will be 5 to the n multiplied by 5 to the power 2. Right, so now we can take a common factor of 5 to the power n. As you can clearly see that we have 5 to the power n as a common factor. Right, if I take 5 to the power n on the first term, I'm going to be left with 2. On the second term, I'm left with minus 5. And then on the third term, I'm left with plus 5 to the power 2. So 5 to the power n multiplied by, so 5 to the power 2, that's 25. And then we have 2 minus 5 minus 3 plus 25. That is 22. So we have 5 to the power n, 22. 22 is an even number. And if we multiply it by any integer, the answer is going to be even. So that's why we say that this expression will always be even for all positive integer values of n. Right, that is 1.3. Let's do 1.4. The last question. Determine the values of x and y if 3 to the power y plus 1 divided by 32 is equals to the square root of 96 to the power x. Right, so we have 3 to the power y plus 1 and we have 32. Can we write 32 with the base of 3? Because usually in a case like this, we're trying to give all the numbers the same base. Well, we can't, but we can write it with a base of 2. So let's go ahead and try that and see what we're going to have. We will have 3 to the power y plus 1 divided by 2 to the power of 5 being equals to square root of 96x. Can we write 96 with a base of 3 or with a base of 2? Well, we can do that at the same time. Why do I say so? We're going to have the square root of. If you want to write 96 using prime numbers, you have 2 to the power 5 multiplied by 3 to the power 1, everything to the power of x. Yes, 2 to the power 5 multiplied by 3 to the power 1 is equals to 96. Let's get rid of the square root on the right hand side. We're going to have 3 to the y plus 1 divided by 2 to the power of 5. We don't have to necessarily square both sides. We can just say that 2 to the power 5 multiplied by 3 to the power 1 to the power x divided by 2. And just like that, we have gotten rid of the square root. So 3 to the power y plus 1 divided by 2 to the power 5 will be equals to 2 to the power 5x divided by 2 multiplied by 3 to the power x divided by 2. This is the same as 3 to the power y plus 1 multiplied by 2 to the power minus 5. We're taking it from the denominator to the numerator. So it must have a minus sign on the exponent. This will be equals to 2 to the power 5x divided by 2 multiplied by 3 to the power x divided by 2. We can equate minus 5 and 5x divided by 2 and y plus 1 with x divided by 2. So if we say minus 5 is equals to 5x divided by 2 and we cross multiply, we're going to get 5x being equals to minus 10. So x is equals to minus 2. Now we have the value of x. So let's go ahead and find the value of y. Y plus 1 is equals to x divided by 2. But we know fully well that x is equals to minus 2. So we're going to have minus 2 divided by 2 minus 1. So minus 2 divided by 2 minus 1 minus 1 minus 1 minus 2. So y is equals to minus 2. The first term of a geometric series is 14 and the sixth term is 448. The first question, 2.1.1, we're supposed to calculate the value of the constant ratio r. So let's go ahead and dissect our information. The first term, t1, is equals to 14. which is just A. So A is equals to 14. On the other hand, T6 is equals to 448. T6 is AR to the power 5. This is equals to 448. But we have the value of A. A is 14. So we have 14 multiplied by R to the power 5 being equals to 448. Now we need to divide both sides by 14. If we do that, we're going to get R to the power 5 being equals to 32. So R to the power 5 is equals to 2 to the power 5. It should be easy to see now that R is equals to 2. This is our common ratio of our geometric series. Let's go ahead and do 2.1.2. Determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Right, so we have a sum Sn which is equals to 114,674,000. We have a common ratio which is equals to 2. Our first term is equals to 14. And we can find the number of terms that will give us a sum of 114,674. So if we just go ahead and find the number of terms required to give us a sum of 114,674 and subtract 6 from that number of terms, we're going to have the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain that sum. Let me show you what I'm talking about. We're going to have Sn being equals to A multiplied by R to the power n minus 1 divided by R minus 1. The sum is 114,674. A is equals to 14, R is equals to 2, n is what we're interested in, minus 1 divided by 2 minus 1. If we cross multiply, this is 2 minus 1, right, which is just 1. We're going to have 114,674 being equals to 14 multiplied by 2 to the power n minus 1. So we are dividing both sides by 14. If we do that, we're going to have 8,191 being equals to 2 to the power n minus 1. If we take minus 1 to the left hand side, we're going to have 2 to the power n being equals to 8,192. So we can take log on both sides. We're going to have n log of 2 being equals to log of 8,192. So n is equals to the log of 8,192 divided by log of 2. Right. If you put that in your calculator, you're going to get 13. In order to get a sum of 114,674, we need 13 terms. So how many consecutive terms must be added to the first 6 terms? That is 13 minus 6, which is equals to 7. So to the first 6 terms, we need to add 7 more terms in order to get a sum of 114,664. Let's move to the following question, 2.1.3. If the first term of another series, so we have A being equals to 448, and the 6th term, so we have AR to the power 5 being equals to 14. Calculate the sum to infinity of the new series. So we have A. Another point of information we need is R. If we substitute A into this equation, we're going to have 448 R to the power 5 being equals to 14. So R to the power 5 is equals to 14 divided by 448. So we can just take everything to the power 1 divided by 5. So 5 and 5 cancels out. We have R being equals to 1 divided by 2. So there we go. We have our common ratio. It is 1 divided by 2. So the sum to infinity will be equals to A divided by 1 minus r. A is 448, and then r is 1 divided by 2. This is equals to 896. And there we go. We have our sum to infinity. 2.2, let's take a look at 2.2 and see what is happening there. So in 2.2, we're given some sigma notation and the sum, right? We're supposed to determine the value of k. Let's make sense of k. K plus 1 is the number of terms we have in our series. Meaning that if we can find the number of terms we have in our series, then k will just be the number of terms minus 1. Okay, so let's go ahead and find the terms of our series. T1 will be equals to, so we substitute in P into this equation. T1 will be equals to 1 divided by 3. P is starting from 0 plus 1 divided by 6. This is just 1 divided by 6, right? And then T2 on the other end, 1 divided by 3 multiplied by 1 plus 1 divided by 6. This is 3 divided by 6. And then T3 will be equals to 1 divided by 3 multiplied by 2 plus 1 divided by 6. This is 5 divided by 6. T1, T2, T3. Let's see how our series looks like. So we have 1 divided by 6 plus 3 divided by 6 plus 5 divided by 6. Do we have a common ratio or do we have a common difference? We need to determine whether it is geometric or arithmetic. 5 divided by 6 minus 3 divided by 6 is 2 divided by 6. 3 divided by 6 minus 1 divided by 6 is 2 divided by 6. So we have a common difference. It means that it is arithmetic. The equation we can use to find the sum, we say that Sn is equals to n divided by 2 multiplied by 2a plus n minus 1 multiplied by the common difference. What is the sum? The sum is given by 21 divided by 6 being equals to n. N is what we're interested in. Multiplied by 2a. A is the first term, which is 1 divided by 6 plus n minus 1 multiplied by the difference, which is 2 divided by 6. So 21 divided by 6 is the same as 20 multiplied by 6. That is 120. You plus 1, so this is 121 divided by 6. Being equals to n divided by 2. And then 2 multiplied by 1 divided by 6 is 2 divided by 6. And then n multiplied by 2 divided by 6 is going to be 2n divided by 6. And then minus 2 divided by 6. As you can clearly see, 2 divided by 6 minus 2 divided by 6 will give us 0. So we just have 121 divided by 6 being equals to n divided by 2 multiplied by 2n divided by 6. So 121 divided by 6 will be equals to 2n squared divided by 12. This is the same as 121 divided by 6 being equals to n squared divided by 6. So we can drop the 6's and just equate the numerators. N squared is equals to 121. So n should be equals to plus 11 and not minus 11. We cannot have minus 11 number of terms. So we have 11 terms, which means that k will be equals to 10. We're given a quadratic number pattern Tn that is equals to n squared plus bn plus 9. And the first term of the first difference is 7. The first question, 3.1, show that b is equals to 4. Let's look at the information we have. We have the equation for the quadratic number pattern, but we have a variable b which we need to figure out. Another piece of information that we have is that the first term of the first differences is 7. It means that t2 minus t1 of the quadratic number pattern will be equals to 7. Let's go ahead and find T2 and T1. So in place of T2, we're just substituting 2 into Tn, right? We're going to have 2 squared plus b multiplied by 2 plus 9 minus T1. So that is going to be 1 squared plus b multiplied by 1 plus 9 being equals to 7. So what is 2 squared? That is 4 plus 2b plus 9. And then 1 squared, we're going to get minus 1. B multiplied by 1, we're going to have minus b, and minus 9 being equals to 7. If we solve that, we're going to get 4 plus 9, 13, minus 1, 12, minus 9, 3. So we have 3. 2b minus b, that is 3 plus b, being equals to 7. If we take 3 to the right hand side, we're going to get b being equals to 7 minus 3, which is just equals to 4. And just like we are required to show, b is equals to 4. That is 3.1. 3.2, determine the value of the 60th term of this number pattern. So we're looking for T60. T60 will be equals to n squared plus 4n plus 9. Now we no longer have b because we have showed that it is indeed equals to 4. So T60 will be equals to 60 squared plus 4 multiplied by 60 plus 9. Now it's just a matter of putting that in your calculator. You shall get 3,849 as the value of the 60th term. That is 3.2. Let's take a look at 3.3. In 3.3, we're supposed to determine the general formula for the sequence of first differences of the quadratic number pattern. And we're supposed to write our answer in the form TP is equals to MP plus Q. Let me show you something. Let's say we have T1, T2, T3, and T4. And we find the differences of 2 consecutive terms, A, B, C. And then now we have our common difference, which is D and D. We're looking for the general term of this sequence, which is going to be linear with a common difference. In order to do that, we need to find T1, T2, T3, and T4, and then compute this and ultimately this. From that, we're going to be able to find the general term. So let's go ahead and find T1. T1 will be equals to 1 squared plus 4 multiplied by 1 plus 9. This is equals to 14. While T2, on the other hand, will be equals to 2 squared plus 4 multiplied by 2 plus 9. This is equals to 21. And then T3 will be equals to 3 squared plus 4 multiplied by 3 plus 9, which is equals to 30. And lastly, T4, we're going to have T4 being equals to 4 squared plus 4 multiplied by 4 plus 9. So 16, 32, 41. So we have T4 being equals to 41. So we're going to have 14, 21, 30, and 41. So let's go ahead and find the differences of these terms. 21 minus 14, that is 7. We know that the first difference of the first two terms is 7. 30 minus 21, 9. And then 30, not 30, but 41 minus 30, that is 11. So we can see that 9 minus 7 will be 2, 11 minus 9 will be 2. So we're looking for the general term of this sequence with a common difference of 2. So we're going to have Tn being equals to A plus n minus 1 multiplied by d, because we have a common difference. This is an arithmetic sequence or pattern. Right, so Tn will be equals to A, the first term. The first term of the arithmetic pattern is 7. So we're going to have 7 plus n minus 1 multiplied by d. We know that d is equals to 2. So Tn will be equals to 7 plus 2n minus 2. So Tn is equals to 2n plus 5. We're supposed to call it Tp and not Tn. So let me just rectify that. Tp is equals to 2p plus 5. There we go. Let's go to 3.4. The last question. So in 3.4, which two consecutive terms in the quadratic number pattern have a first difference of 157? Which two terms in the quadratic number pattern has a first difference of 157? This is a very common question. Well, we have the formula for the first differences. So we can find the position of 157 in the pattern of the first differences. So Tp is equals to 2p plus 5. And in which position is 157 situated? 2p plus 5. Let's go ahead and find the value of p, the position of 157 in the general term of the first sequences. So 157 minus 5, that will be 152 being equals to 2p. So if we divide both sides by 2, we get p being equals to 76. Let me show you something. T1 of the first differences is between T2 and T1 of the quadratic. And then T3 is between T4 and T3. If 157 is in position 76, it would mean that it is between T77 and T76.
Sketch below is the graph h of x. So we have h of x being equals to 1 divided by x plus p plus q. The asymptotes of h intersected a coordinate 1, 2, right? That's where we have our coordinate sim, right? Let's just call it a sim. And then 4.1.1 says that let's write down the values of p and q. The values of p and q. So q is the horizontal asymptote, right? So q is equals to 2. We can see it here from our graph, right? That's from our general knowledge of a hyperbola. So q is equals to 2. That's what we know, right? And then now we're looking for p, right? So if you look at this equation of the hyperbola here, we have x plus p, right? So to find p, you say x plus p is equals to 0, right? So x is equals to minus p. But then from our graph, we have the value of x. X is 1, right? So now you can see that minus p is just equals to 1. So if you solve for p here, you're gonna get p is equals to minus 1. So q is equals to 2 and p is equals to minus 1, right? Hence we have our asymptote at x is equals to 1, because if x is 1, then we have 1 divided by 0, which we're not supposed to have. Let's do 4.1.2. So 4.1.2 is saying that let's calculate the coordinates of the x-intercept of h. So as soon as I hear x-intercept, I'm letting y be equals to 0, right? So from h of x, I'm going to put 0, and then we have 1 divided by x minus 1 plus 2, right? So now if we take 2 to the other side, we're going to get minus 2 is equals to 1 divided by x minus 1. So minus 2x plus 2 is equals to 1. So minus 2x is going to be equals to 1 minus 2, that will be minus 1. So x is equals to 1 divided by 2. So our coordinate is 1 divided by 2 and 0. Let's do 4.1.3. 4.1.3 says that let's write down the x coordinate of the x-intercept of g. If g of x is equals to h and then x plus 3, right? So let's understand what g of x is doing to h of x. G of x is moving h of x 3 units to the left. If we have plus 3, we're moving 3 units to the left. If we have minus, we're moving 3 units to the right. It's counterintuitive, I know, but then it is what it is. So g of x, you just move h of x 3 units to the left, right? So if the x-intercept was at 1 divided by 2, now we have to move it 3 units to the left. How can we move it 3 units to the left? We're gonna say 1 divided by 2 minus 3, right? That's exactly what you're gonna say. And if we compute this, we're saying that x is equals to 1 divided by 2 minus 3, which will be equals to minus 2.5, right? So the new x coordinate of the x-intercept will be x is equals to minus 2.5 because we have moved h of x 3 units to the left. Now let's do 4.1.4. 4.1.4 says that the equation of an axis of symmetry of h is y is equals to x plus t. Determine the values of t. So we are given the slope, right? We just have to find t. So if you have an axis of symmetry, the point you substitute is this point here, where the axis of symmetry intersect. You substitute that point if you want, where the asymptotes intersect, I meant. That's the point you substitute if you want to find an equation of the axis of symmetry. So if we substitute that point, right, we're gonna get 2 being equals to 1 plus t, so 2 for the y and 1 for x. Yeah, so we're gonna get 1 is equals to t. So the axis of symmetry is y is equals to x plus 1, and we just asked to find t, and then there we have t. So I think we're good to go. The last question, 4.1.5, says that let's determine the values of x for which minus 2 is less or equals to 1 divided by x minus 1. Let me show you something. If we take minus 2 to the right hand side, we're going to get 0 being less or equals to 1 divided by x minus 1 plus 2. And this is the equation we have in the graph, right? So what this question is asking us is to find the values of x for which the graph is at 0 or above, right? The values of x for which the graph is at 0 or above, right? So let's look for that. Let me just erase this so that we can have a bit of clarity. So let's go to our graph, right? We don't have to do this algebraically. Obviously you can, but then we don't have to if we have the graph already. So let's look at the graph. We can see here that for this part of the graph, this part here, the graph is greater than 0, right? So for all those values of x on that part, they satisfy what we're looking for. So we can say that when x is greater than 1, our equation is satisfied because h of x is clearly greater than 0, right? Now let's look at the other wing. We know that the x-intercept is here, right? And we've calculated it. That's when x is equals to 1 divided by 2, right? But if we go to the left, then our graph h of x is above 0, right? So on that side, we can say that when x is less or equals to a half, our equation is satisfied because h of x is either equals to right at x is equals to 1 divided by 2 or greater than when x is less than 1 divided by 2. Now I'm under the impression that if the sketches look complicated, then the questions are actually easy. And then if the sketch look kind of plain, and then the questions might be hard. So let's see what's happening in this question here, right? So for 4.2.1, the question is saying that let's write down the y coordinate of C, right? So clearly we have two graphs here, f of x, which is x squared minus 4x minus 5, right? Which is the quadratic function you see on the graph. And then we have an exponential function, g of x, right? Which is a multiplied by 2 to the x plus q. And then e and h are the x-intercept. We have e here, as you can see, and then we have h here being the x-intercept. So this line here is actually our x-axis, and this line here is our y-axis, right? And then C is the y-intercept of f. So we have C here being the y-intercept of f, and it lies on the asymptote of G. Okay, C is the y-intercept and it lies on the asymptote of G. The two graphs intersect at D, so they're intersecting here at D, the turning point of f. So the first question, the y coordinate of C. So C is the y-intercept of f, right? So if we're looking for the y-intercept, we always let x be equals to 0, right? So for that function f of x, if we do that, we're going to get f of 0 being equals to 0 squared minus 4 multiplied by 0 minus 5, right? So it should be easy to see here that f of 0 is going to be equals to minus 5, right? So the coordinate, the y coordinate of C is clearly minus 5, right? Because that's what we get when we let x be equals to 0. And then the next question, 4.2.2, let's determine the coordinates of D. D is the turning point of f of x, right? So we have f of x, let's not forget, being equals to x squared minus 4x minus 5, right? If we want to find the coordinates of the turning point, it's beneficial if we start with the x value of the turning point, right? Because we have a formula for that. We can say that x will be equals to minus b divided by 2a. So this will be equals to, so b is the coefficient of x, right? So that's supposed to be minus 4. And then a is the coefficient of x squared. So we're just going to have 1 there. So now we can see that x at the turning point should be equals to 2, right? Now that we have that 2 there, we're just going to substitute it in the equation f of x, right? F of 2 being equals to 2 squared minus 4 multiplied by 2 minus 5, right? So this will be equals to, so we have 4 minus 8 minus 5, and that should be equals to minus 9, right? So the coordinates of D, we have 2 for the x value and minus 9 for the y value, right? It's easy to see. Now let's do 4.2.3. So 4.2.3, we're looking for the values of a and q, right, from our graph g of x. So g of x is equals to a multiplied by 2 to the x plus q, right? Q is the asymptote of our graph, but we are told that the asymptote of G is at the y-intercept of f. So now we can easily say that Q is equals to minus 5. So if Q is equals to minus 5, then we have G of x being equals to a multiplied by 2 to the x minus 5, right? So now what we can do here, we can substitute the coordinate D so that we can find A, right? D has coordinates 2 and minus 9, because D lies on f of x and g of x, so we can substitute it in that equation. So if we substitute it, we shall get minus 9 is equals to A multiplied by 2 to the 2 minus 5, right? So minus 9 equals to 4A minus 5, right? So minus 4 is equals to 4A. So a is equals to minus 1, right? So we have determined the value of a, and we have determined the value of q, right? Let's do 4.2.4. So 4.2.4 is saying that let's write down the range of g, right? So we have g of x being equals to minus 2 to the x minus 5, and we're supposed to determine the range of the graph, right? We can just easily look at the sketch here, right? Because as you can see, the y values will never be greater than minus 5, right? They actually never touch there. The y value gets approximately, it gets infinitely closer to minus 5, but then it never really touches minus 5, right? But then going down, the y value goes to minus infinity, basically, right? So we're saying that the y value will always be less than minus 5, right? The y value is always going to be less than minus 5. So 4.2.5, determine the values of k for which the value of the value of what? F of x minus k will always be positive, right? If we come to our graph f of x here, our turning point is here at D, where the y value is minus 9, right? So we know if we have f of x plus 3, then that moves the entire graph 3 units up, and then if we have f of x minus 3, then that moves the entire graph 3 units down, right? Then we have to shift it more than 9 units up, right? If we want our graph to always be positive, because if we shift it more than 9 units up, then it's going to be above the axis, so all the values will be positive, right? But here, the tricky thing is here, we have f of x minus k, right? So if k here is less than minus 9, then we will have shifted our graph enough units such that the entire function f of x is positive.
We have two functions, g of x and the g inverse. We're supposed to find the y coordinate of b, the y-intercept of g of x. We are given the equation g of x being equals to 2x plus 6. If you want to find the y-intercept, you let x be equals to 0. So we're going to have g of 0 being equals to 2 multiplied by 0 plus 6. So y is going to be equals to 6. 2 multiplied by 0 is just 0. So that is the y coordinate of b. 5.1. Let's take a look at 5.2. Determine g inverse in the form g inverse is equals to mx plus n. We know that g of x is equals to 2x plus 6. In order to find the inverse, we need to swap x and y and solve for y. So in place of y, we're going to put x, and in place of x, we're going to put y plus 6. So 2y is equals to x minus 6. We just need to divide both sides by 2. So we're going to get y being equals to 1 divided by 2x minus 3. This is the equation of g inverse. Now we can conclude and say that g inverse of x is equals to a half x minus 3. Let's move to 5.3. In 5.3, we're supposed to find the coordinates of a. Let's go ahead and take a look at a. A is where g of x and g inverse touch. So in order to find the coordinates of a, we have to equate the two equations. If we do that, we're going to have 2x plus 6 being equals to a half x minus 3. Let me take a half x to the left hand side. If I do that, I'm going to get 3 divided by 2x being equals to minus 9. I'm taking plus 6 to the left hand side. I'm going to get minus 3 minus 6, which is minus 9. Now what I have to do is to divide both sides by 3 divided by 2. If I do that, I get x is equals to minus 6. So that is the x value at a. Now I just have to substitute x is equals to 6 into g of x or g inverse. If I substitute it into g of x, I'm going to get 2 multiplied by minus 6 plus 6. So 2 multiplied by minus 6, that is minus 12. Minus 12 plus 6 is minus 6. So the coordinates of a is minus 6 and minus 6. That is 5.3. Quite easy to compute. Let's take a look at 5.4. In 5.4, we're looking for the length of AB. We have the coordinates of A and we have the coordinates of B. So finding the length of AB should be pretty much straightforward. We're going to have AB being equals to, we're going to use the distance formula. That is x2 minus x1 squared plus y2 minus y1 squared. This will be equals to. So the coordinates of B, we have 0 and 6. The coordinates of A, we have minus 6 and minus 6. If we take B as our second point, we're going to have 0 minus 6. So that is just 0 plus 6 squared plus y2. Y2, the y value of B is 6. So that will be 6 minus 6. So that is 6 plus 6 squared. So this will be 6 squared, 36, and then 12 squared, 144. 144 plus 36, 180. So AB is equals to square root of 180. Obviously, you can further simplify that and get 6 square root of 5. AB, let's do 5.5, the interesting question really. So in 5.5, we're supposed to calculate the area of triangle ABC. So let's just go ahead and highlight that triangle. There's quite a couple of ways we can use to find the area of triangle ABC. Let's just try this first. We can find the area of triangle DBC. Let me highlight it. We can find the area of this triangle. How can we possibly do that? We have the base DC and we have the height OB. We have the length of DC and we have the length of OB. And we can also find the area of triangle DAC, this area right here. We have the base DC again, but now we have this height of which we know the length, right? So we can go ahead and say that the area of triangle ABC is equals to the area of triangle BDC plus the area of triangle DCA. This is going to be equals to a half base. The base of triangle BCD is DC. What is the length of DC? The x-coordinate of C is 6 and the x-coordinate of D is minus 3. So from D to C is 9 units. So we're going to have that there. And then the height from O to B is 6 units. The y-coordinate of O is 0 and the y-coordinate of B is 6. So we're going to have 9 multiplied by 6 plus the area of triangle DCA. The base is DC. We know that DC is 9 units. And then now let's talk about this height. The y-coordinate A is minus 6 and the y-coordinate at the x-axis it is 0. So that distance should also be equals to 6. This is equals to 54 units squared. 12,000 was invested in a fund that paid interest at M% per annum, compounded quarterly. After 24 months, the value of the investment was 13,459. Determine the value of M. Let's go ahead and dissect the information we have. Our principal amount is 12,000 and our accumulated amount is 13,459. Our interest is what we're supposed to find, M%, which is just M divided by 100. It is compounded quarterly. Right, we know what to do with that information. After 24 months, the value of the investment was 13,459. So how many quarters do you have in 24 months? N is equals to 8. We're going to have the accumulated amount being equals to the principal amount multiplied by 1 plus I, everything to the power N. The accumulated amount is 13,459. The principal amount, 12,000 multiplied by 1 plus I, the interest, which is M divided by 100. Everything divided by 4. Why are we dividing by 4? Because it is compounded quarterly. Everything to the power 8. The most organic step is dividing both sides by 12,000. If we do that, we're going to have 1 plus M divided by 400, everything to the power 8, being equals to 13,459 divided by 12,000. M divided by 100 divided by 4 is the same as M divided by 400. So we can just write that instead. Now what we want to do is get rid of this 8. How do we do that? on the left hand side, we're going to have 1 plus m divided by 400, everything to the power 8, everything to the power 1 divided by 8. We want 8 and 8 to cancel out, but we have to do the same thing on the right hand side. On the right hand side, we're going to have 1.121 to the power 1 divided by 8. We are going to have 1 plus m divided by 400 being equals to 1.121, everything to the power 1 divided by 8. It's obvious what we need to do at this point. We need to take 1 to the right hand side and multiply both sides by 400. We're going to have m being equals to 1.121, everything to the power 1 divided by 8 minus 1 multiplied by 400. That's all we need to do to find the value of m, which is equals to 5.78%. Let's go ahead and do 6.2. In 6.2, on Jan 31st, somebody deposited 1,000 in an account that paid interest at 7.5% per annum compounded monthly. Right, we need to note that he continued depositing 1,000 on the last day of every month. He will make the last deposit on 31st December 2022. Will Tino have sufficient funds in the account on 1 Jan 2023 to buy a computer that costs 13,000? Justify your answer by means of an appropriate calculation. Let's make sense of our situation. So the first deposit is on the 31st of Jan, and the last deposit will be on the 31st of December. So that is 12 deposits, our value of n. So we have n being equals to 12. We have our monthly installments or our monthly savings being equals to 1,000. What is another piece of information we have? We have the interest, which is equals to 7.5% compounded monthly. How much money is he gonna have at the beginning of the following year? That's what we're trying to figure out. We're gonna have the future value. This is future value because we are saving money and making monthly contributions. It's gonna be equals to x multiplied by 1 plus I, everything to the power n minus 1, everything divided by I. Let's go ahead and substitute. The value of x, our monthly contributions, that is 1,000 multiplied by 1 plus the interest, which is 7.5%, divided by 12. We divided by 12 because it is compounded monthly. Everything to the power 12 minus 1 divided by the interest. The interest again, 7.5%. We still dividing that by 12 because it is compounded monthly. If you put that in your calculator, you're going to get 12,421.22 rands, which is less than 13,000. We are not going to be able to purchase that computer that costs 13,000 because our future value is less than that. That is 6.2. Let's take a look at 6.3, 6.3.1. So Tabo plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. 6.3.1, let's calculate the value of the loan. So he wants to buy a car that costs 250,000. He will deposit 15% of that amount and finance the rest. So what is the value of the loan? The value of the loan is equals to 250,000 multiplied by 85%. The 15% is the deposit he is deciding to pay. So what is the amount of the loan? The amount of the loan will be equals to 212,500 rands, 6.3.2. The first payment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. We need to make note of something. He only starts repaying the loan 6 months after it has been granted. So during that 6 months, for the 5 months after the first month of taking the loan was accumulating interest. We are only considering the 5 months because the month you take the loan, it is not going to accumulate any interest. So we're going to have A being equals to P, 1 plus I, everything to the power N. So the new loan will be equals to the principal, which is 212,500 rands multiplied by 1 plus the interest, which is 13% compounded monthly. So that will be 13% divided by 12, everything to the power 5, like we are saying. If you put that in your calculator, you're going to get 224,262.53 cents as the balance 6 months after the loan has been granted. Let's go ahead and compute the next part of our problem. We know fully well that when we are repaying a loan, we use P is equals to X multiplied by 1 minus 1 plus the interest, everything to the power minus N, everything divided by I. This is the monthly installments we're looking for. And P is the loan amount or the value, which is 224,263 rands 53 cents. So we're going to have 263.53 being equals to X. Everything multiplied by 1 minus 1 plus the interest, 13%. We divide that by 12, everything to the power minus N. So let's make sense of that minus N. So he's repaying the loan in 6 years, right? Let's concentrate on the first year. There's something that is happening there on the first year. The other 5 years, we just have 5 multiplied by 12, which is equals to 60. But what about the first year? How many payments are we going to make in our first year? Let's say the loan is being granted in Jan. So in Jan, it's not going to pay Feb, March, April, May. But at the end of the 6th month, which is June, he's going to make the first payment. So he's going to make a payment in June, July, August, September, October, November, December, which is 7. So he's going to make 60 plus 7 payments, which is 67. So that is our value of N. We need to familiarize ourselves with those kind of situations. So we have minus 67. The value of N is not 66 but 67, and that is a very common mistake. We are dividing everything by the interest, which is 13% divided by 12. We want to find the value of X, which will divide both sides by this coefficient of X. So X will be equals to 224,263.53 divided by the coefficient of X. This will be equals to 4,724 rands 96 cents.
First principles. So it's the limit as h tends into 0 of f of x plus h minus f of x, everything divided by h. So this part here, f of x plus h, we just take in the function itself, right? F of x, and everywhere where there is x, we put x plus h, and then minus f of x, we just subtract f of x. There's nothing special we're doing. So f prime of x will be equals to the limit as h tends into 0 of our function is x squared plus x, right? So we're gonna have x plus h in place of x, right? and then here again we're gonna have x plus h, and then we subtract f of x, the function itself, right? So we say in minus x squared plus x, and then we can divide everything by h. So f prime of x will be equals to the limit as h turns into 0 of, so we have x plus h squared, so x multiplied by x, that is x squared, and then x multiplied by h, that is xh. You multiply that by 2, you get plus 2xh, and then h by h, that is just h squared, right? And then plus x plus h, and then minus x squared, and then minus x, and then everything being divided by h. It should be easy to see here now that x squared minus x squared, so that's gone, right? And then we have x, and then we minus x, so that also disappears. So now we have f prime of x being equals to the limit as h turns into 0 of 2xh plus h squared plus h divided by h. So right now we're gonna take h as a common factor on the numerator, right? So we're gonna have the limit as h turns into 0 being equals to h. We have 2x, and then plus h, and then plus 1 divided by h, right? We just took h as a common factor. It's easy to see now that h in the denominator will cancel out with h on the numerator. So now we just left with 2x plus 1, right? And that's exactly what we're expecting, because if you derivate x squared plus x using the power rule, you expect to get 2x plus 1. Now let's do 7.2. 7.2 is quite straightforward, right? It says that let's find f prime of x if f of x is equals to 2x to the power 5 minus 3x to the 4 plus 8x. We're using the power rule, right? We know fully well that the power rule is saying that the derivative of x to some power n should be equals to nx to the power n minus 1. So if we apply this here, we're gonna get f prime of x being equals to 2 multiplied by 5, and then x to the 5 minus 1 minus 3 multiplied by 4, and then x to the 4 minus 1, and then plus 8 multiplied by 1, and then multiplied by x to the 1 minus 1. That should be equals to, so we have 2 multiplied by 5, 2 multiplied by 5, that is 10, and then 5 minus 1, that is 4, so we have 10, x to the power 4, and then minus 3 by 4, that is 12, and then x to the 3, 8 by 1, that is 8, and then x to the power 0 is 1, right? And the number to the power 0 is 1. And just like that, we already have 8 marks. And now let's do 7.3. So 7.3 is saying here that the tangent to g of x, if our function g of x is equals to ax cubed plus 3x squared plus bx plus c, has a minimum gradient at the point minus 1 and minus 7, right? For which values of x will g be concave up? For which values of x will g be concave up? I think if there's one thing we can agree on here is that this question will be extremely easy if we knew the value of a and the value of b, and then maybe I forgot plus c here. So maybe, you know, let's give it a try. Let's see if we can find ABC. If we find ABC, then we're just gonna derivate twice, equate to 0, and then we're gonna be able to find for which values of x will g be concave up. So let's, you know, go ahead and look at our equation and see what we can do here. So we can see here that the tangent, right, to g of x. So the tangent to g of x, let's find the equation of that tangent. So we're saying that g prime of x, we're trying to find the tangent to that graph. That will be 3ax squared, we just applying the power rule, right, plus 6x plus b, right? So now we have this tangent, right? Let's go ahead and substitute that point minus 1 and minus 7 and see what we can do here. So if we substitute minus 1 and minus 7, we're gonna get minus 7 being equals to 3, and then a, and then minus 1 squared plus 6 minus 1 plus b, right? So we have minus 7 being equals to minus 1 squared, that will just be 3a, and then minus 6 plus b, right? So we can go ahead here and make b the subject of the formula, right? So that we don't have to divide, because if you make a the subject of the formula, you're gonna have to divide both sides by 3, and we don't want to do that. So if we do that, we're gonna get minus 7 plus 6, that will be minus 1, and then we take 3a to the other side, we get minus 3a being equals to b, right? So this is our equation 1, because you can see now we have 2 variables. So we need to think of another way we can use to find another equation, and then it will be straightforward. We are going to use the fact that minus 1 and minus 7, we find the minimum gradient of this graph here. We find the minimum gradient of this graph, so we can derive that equation again and equate to 0. Let me show you what I'm talking about. So we can say that g prime of x basically is equals to so if we derive that will be 6ax plus 6 being equals to 0, right? That's where the minimum gradient is. Minimum gradient is equals to 0. So again, we know the x value of that point. It is minus 1, right? So we can substitute that minus 1 in our equation. If we substitute that minus 1 there, we're gonna get 6a minus 1 plus b is equals to plus 6, not b, plus 6 is equals to 0. So here you're gonna see that minus 6a is equals to minus 6, so a is equals to 1. Right? So now we have determined that a is equals to 1. Now let's go to equation 1, to this equation here, and substitute 1 so that we can find b. If we do that, we're gonna say minus 1 minus 3 multiplied by 1 is equals to b. Minus 4 is equals to b, right? So now we have the value of a and we have the value of b. Let's substitute them in our graph g of x, right? Because like we have already agreed on, if we find a and b, it becomes extremely simple to find for which values of h will g be concave up. So now we're saying that g of x is equals to, in place of a, we put 1 and then x to the 3, right? And then plus 3x to the 2 plus bx. So we know that b is minus 4, so minus 4x plus c, right? So now we have g of x is equals to x cubed plus 3x squared minus 4x plus c, right? So now we have this equation here. The only unknown variable we have is c, but then c doesn't really matter, right? It won't affect us with much, because for us to find the x value at the point of inflection, we have to derive twice, and when we derive twice, c is gonna fall apart, right? Because for us to know for which values will g be concave up or down, we need the x value of the point of inflection, right? I can tell you already that x value will be minus 1, because that's where the minimum gradient of the tangent is. But you don't have to believe me. Let's just work it out. So if we derive this twice in attempt to find the point of inflection, we're going to say that g prime of x will be equals to 3x squared plus 6x minus 4, right? And then we derive it again, we get 6x plus 6, right? And then this is equals to 0. So it should be easy to see now that x will be equals to minus 1, right? So our point of inflection is minus 1. Now let's look at our graph g of x, right? The coefficient of x to the power 3 is positive. If the coefficient of x to the power 3 is positive, our graph should look like this. So this is how our graph will look like, right? And we're saying that our point of inflection is somewhere here at minus 1, right? We're looking for the values of x of which our graph g is concave up, right? So this is concave up, right? Because our graph is ultimately going up. So when x is greater than minus 1, our graph is concave up. The graph of y is equals to f prime of x is equals to mx squared plus nx plus k is drawn below. The graph passes through points P, Q, and R clearly, as you can see on the sketch, right? And then the first question, 8.1, is saying let's determine the values of m, n, and k, right? So we're given here that y is equals to mx squared plus nx plus k, right? And we're given the function and 3 points. As you can see here, we have 3 variables, m, n, and k, right? And we have 3 points. So with 3 variables and 3 points, we can set up 3 equations to try and find the answer, right? But then the easy way you would do this equation is if you substitute point r first, right? Because r is a y-intercept. When you substitute r, you're gonna get the value of k, right? So if we go ahead and substitute r, we're gonna get 1 is equals to m multiplied by x squared, x is 0, right? And then n multiplied by x, x is 0 again, plus k, right? M will fall away because we multiplied by 0. The same is true with n. So now we're left with 1 is equals to k, right? So now we know the value of k. So our function will become y is equals to mx squared plus nx plus 1, right? Now we just left with m and n, and we have the 2 points, right? So with the 2 points, let's see how we can determine m and n. So let's substitute point q first of coordinates 1 and 0, right? If we substitute that point, we're gonna get 0 is equals to m multiplied by 1 squared plus n multiplied by 1 plus 1, right? So we have minus 1 minus m being equals to n, right? Here I just took 1 and m to the left hand side, and then we can call this equation 1, right? From here we can substitute our point p, which is minus 1 divided by 3 and 0 in our equation, right? If we do that, we're gonna get so the y value is 0, so we're gonna get 0 is equals to m multiplied by minus 1 divided by 3 squared plus n multiplied by minus 1 divided by 3 plus 1, right? So we're gonna get minus 1, I'm taking this one here to the left hand side, being equals to 1 divided by 9m minus 1 divided by 3n. So again, let's make n the subject to the formula and equate the two equations, right? We're gonna get minus 1 minus 1 divided by 9m being equals to minus 1 divided by 3n. So we're gonna divide everything by minus 1 divided by 3, right? So if we say minus 1 divided by minus 1 divided by 3, that should give you 3. And then if you say 1 divided by 9 divided by 1 divided by 3, right? The negatives will cancel out. You will get plus 1 divided by 3m is equals to n. So now what are we saying? We're saying that minus 1 minus m, so let's call this equation 2, right? So if we equate equation 1 and 2, we're gonna get minus 1 minus m is equals to 3 plus 1 divided by 3m. All these two equations are equals to n, so they should be equals to each other, right? So if we rearrange, we get minus 1 minus 3 is equals to 1 divided by 3m plus m, right? So minus 1 minus 3, that will be minus 4, and then 1 divided by 3m plus m will be 4 divided by 3 m, right? So if we divide both sides by 4 divided by 3, we're gonna get minus 3 is equals to m. So now we can substitute this value of m in either equation 1 or 2, right? Equation 1 is more easy to digest, so let's substitute it there, right? So equation 1 was saying that minus 1 minus m is equals to n, right? So this will be minus 1 minus 3 being equals to n. So it's just minus 1 plus 3 is equals to n. So 2 is equals to n. So our equation now is y is equals to minus 3x squared plus 2n plus 1, right? We have determined the value of k. We have determined the value of n and m. Let's move to the second question, 8.2. 8.2 saying that it is further given that f of x, right? F of x is equals to minus x cubed plus x squared plus x plus 2. 8.2.1 says let's determine the coordinates of the turning points of f, right? And then let's look at the marker location. The marker location is 3, right? So here, when we derivate this equation, right, we're going to get y. When we derivate f of x, we're going to get this equation y, right? And then we're gonna equate this equation to 0. When we equate this equation to 0 and we solve for x, we're going to get x is equals to minus 1 divided by 3 and x is equals to 1. We can just substitute these two values into f of x, right? So one turning point is going to be at f of minus 1 divided by 3. That is because if you want to find the x coordinates of the turning point, you derivate the equation once and you equate it to 0, right? Because the gradient there is equal to 0. So if we substitute that, we're going to get minus and then minus 1 divided by 3 to the 3 plus minus 1 divided by 3 squared plus minus 1 divided by 3 plus 2. I'm getting 49 divided by 27, right? Which I'm just going to round off to 2 decimal places and write it as 1.81, right? Now let's substitute the other point, which is 1. So we're going to have minus and then multiply by 1 to the 3 plus 1 to the 2 plus 1 plus 2, right? And that should be equals to 3. Now let's move forward and do 8.2.2. So the coordinates, let's just conclude there before we move forward. So the coordinates there will be minus 1 divided by 3 and 1.81, right? And then the other coordinate is 1 and 3. Those are the coordinates of the turning point of f. Let's do 8.2.2. 8.2.2 is saying that let's draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts with the axis. So we already have the turning points, right? The turning points figured out. Now we just need the intercept with the axis, right? So let's find the y-intercept, right? The y-intercept should be easy to see. That if we say f of 0, all the x's are going to fall apart and we're just going to have f of 0 being equals to 2, right? So we have figured out the y-intercept. Now let's look for the x-intercept, right? So we have minus x to the 3 plus x squared plus x plus 2 being equals to 0, right? So what's happening here? We're supposed to solve for x, right? If you use trial and error here, you will find out that the only value of x that is real that will satisfy this equation is when x is equals to 2, right? So this is the x-intercept, we have the y-intercept, and we have the turning points. Now we can sketch our function, right? So let me just put our axis there and see what we can do. So there go our axis. Let's put the turning points first, right? So the turning points, we have minus 1 divided by 3 and 1.81, right? So let's put 1 here, let's put 2 here, let's put 3 here. So 1.81 should be somewhere here. So we have a point there. Now let's look at the other turning point, 1 and 3, right? 1 for the x value and 3 for the y value. So we have another turning point there. Now let's look at our intercepts. The y-intercept is here at 2 and the x-intercept is also at 2, right? So we have another point here. So when we sketch our cubic function, it's going to look something of this manner. So there goes our cubic function. It must go through 2 and then it must turn here, right? at 3, and then we go down to 2 for the x-intercept, and there we go, right? It doesn't look so great, but yeah, you can see what's happening here. Now let's do 8.3. So 8.3 is saying that points E and W are two variable points on f prime of x, right? This function that we have here drawn for us, right? That function there. And then they lie on the same horizontal line, right? So let's just, put a horizontal line there so that we can better conceptualize what's going on. So let's say we have some horizontal line there. Let me just use a ruler because I do have one. Why should I make everything look so messy? So there goes our horizontal line, right? It's not exactly there, right? It might be below the axis, it might be above. I'm just, putting a horizontal line for the sake of clarity. Now, the question goes on to say that H is a tangent to F at E. So let's say maybe our coordinate E is somewhere here, right? It's somewhere here. And then our coordinate W is somewhere here. Then if H is a tangent at E, then H should touch E there, and then yeah, it can look like that, right? And then G is a tangent at W, so it can look like that, right? Then these two lines must go up until they touch somewhere up there, right? And then the first question, 8.3.1, is saying that let's write down the value of A. Let's write down the value of A. And then the question has 1 mark. Now I want you to realize something here, right? If indeed these two tangents lie on E and W, and E and W lie on the same horizontal line, then this point here should be at the x of the turning point. So if we want to find the value of A, we're gonna say A is equals to minus B divided by 2A, right? Back to the basics, the x coordinate of the turning point. So we're gonna have minus, we have the equation of that graph there, right? We just determined it above. So here it is here. So B is 2 and A is minus 3. So here we're gonna have 2 and then divided by 2 multiplied by minus 3. So that will be 2 divided by 6, which is equals to 1 divided by 3. So the value of A is 1 divided by 3. Now let's do 8.3.2. 8.3 is saying that determine the values of B for which A and G will no longer be tangents, right? The value of B for which H and G will no longer be tangents to F. Now let's go to a sketch so that I can show you something, right? So let me just erase these tangents here, right? Let me just erase those tangents. So we can have tangents that look like this, right? And we won't have any problem, right? And we can have tangents that look like this, that go very up. We still won't have any problem, right? Let's assume that they are touching here, right? We won't have any problem. We can even have the tangents touching here on the y value of the turning point. But then if the two lines start touching at a value that is less than the y value of the turning point, then those two lines will no longer be tangents because they're going through the graph. They're no longer just touching it once. For instance, let's say we have something like this. Then obviously these two lines won't be tangents anymore because they're going through the graph. They're not touching it once, right? So if those two lines touch at some point that is less than the y value of the turning point, then those two lines can no longer be a tangent. So basically we're just calculating the y value of the turning point, right? And then say that when B is less than the y value of the TP, then those two lines are no longer tangents. So let's go ahead and calculate the y value of the turning point. we know fully well that the x value is 1 divided by 3, right? So now if we want to find the y value, we're gonna get y is equals to minus 3 multiplied by 1 divided by 3 squared plus 2x, right? What is x? 1 divided by 3 and then plus 1, right? Don't forget the equation of y. And that should be equals to 4 divided by 3. So the value of b shouldn't be less than 4 divided by 3. If it is less than 4 divided by 3, then issues arise. F of x is equals to x squared. Determine the minimum distance between the point 10 and 2 and a point on F. It will be a really painful exercise if we calculated the distance between every point on F and this point that we given, right? Instead, let's do it for the function as a whole instead of doing point by point, because we'll never really reach to the end, right? So if we do it for the function itself, we can say that the distance is equals to, we know fully well, y2 minus y1 squared plus x2 minus x1 squared. Distance formula, right? Grade 10, nothing complicated. So now our distance will be equals to, so we have y2. Now this is where it gets complicated, right? What is y2 and which one is y1? Obviously, we have our point here that is given to us, right? It's easy to see that we can make this 10 be x1 and let the 2 be y1. And then for x2 and y2, we're going to use the function itself, because for every point on the function f of x, right, we're going to have some coordinate x and the corresponding y value x squared, right? That is what this function is essentially doing, right? So if we substitute that in our function, so let's let this be x2 and let this be y2. So if we substitute this in our function, we're gonna get x squared minus y1, which is 2, and then we square everything, plus x2. x2 is x, and then minus x1, which is 10, and then we square everything, right? If you've been watching my videos, you know fully well that I don't like square roots, fractions, and all that, right? So I'm just going to square both sides so that I don't have to deal with the square root. If I do that, I'm gonna get the distance squared being equals to x squared minus 2 squared plus x minus 10 squared, right? So now you can see that it's much easier to digest, right? But then the brilliant thing about distance is that if the distance from A to B is greater than the distance from C to D, right? Even if you compare the squared distances, the distance between C and D will still be greater. So instead of using the distance, we can just use distance squared, because it makes our life more simple, right? So let's just go ahead and use distance squared, because we're all agreeing that it makes our life simple. If I go ahead and simplify this, I'm going to get d squared is equals to x squared by x squared. That will be x to the power 4, right? And then minus 2 multiplied by x squared, that will be minus 2x squared. You multiply that by 2, you get minus 4x to the 2, and then minus 2 multiplied by minus 2 plus 4, then x by x, that will be x squared, and then minus 10 by x minus 10, multiply that by 2, you get minus 20x, and then 10 by 10, that's 100, right? So now we have d squared being equals to x to the 4, x to the 4, x to the 4, minus 3x squared, and then minus 20x plus 104. So now we have our equation for distance squared, right? But then we don't want just the equation for distance squared. We want the minimum distance between a point on the function and our point 10 and 2, right? So the way we are going to do this, if we derive distance squared and equate to 0, then that value of x that we're going to determine is going to be the value of x on the point that gives us the minimum distance. And then after that, we're going to calculate the minimum distance. So let me go ahead and derive this. So if I derive this, so I'm saying the derivative of distance squared will be equals to x to the 4 we just apply the power rule. So that will be 4x to the 3 and then minus 6x minus 20. We're equating it to 0, right? We want the point that will give us the minimum distance. So now all we have to do is to solve this equation here, and we have the value of x of that point, and with the value of x of that point we can substitute it in our distance formula and consequently find the minimum distance between the point and a point on f, right? So when we solve something like this, we always going to have a bracket here that says x plus some number k, right, multiplied by a quadratic function being equals to 0, right? So the way you solve this, you start with this bracket here, right? You use trial and error and try a few values until you get 0, right? After you solve this bracket here, it becomes easy to find this other bracket. So let's go ahead and try a few values and see which value that when we substitute in this equation we're gonna get 0, right? Because if we substitute that value and we get 0, then we know that that value is a factor of this equation. So I'm gonna try 0, 1, 2 and minus 1 and minus 2, right? So let me try 0. So if I try 0 there, let me just substitute in real quick. If I try 0, I'm getting minus 20 if I try 0, right? Obviously. Let me try 1 and see what I get. If I substitute 1 in that equation, I get minus 22. Let me try minus 1. If I try minus 1, I get minus 18. That's not what we want. Let me try minus 2. If I try minus 2, I'm getting minus 40. So let me just try 2. And then when I try 2, I get 0, right? So I know that when x is equals to true, this equation here, it holds, right? 4x to the 3 minus 6x minus 20 will be equals to 0 when x is equals to 2, right? So when x is equals to 2, that's exactly where we have our minimum, right? But the good part about all of this is that we can actually verify and see if we get our minimum when x is equals to 2, right? We can substitute x is equals to 2 on this distance formula here that we started with, right? And then we can substitute 2.1 and substitute 1.9, right? Because if we substitute a value that is slightly above 2 and a value that is slightly below 2, and all those two values give us a bigger distance than when we substitute 2, then 2 is the value we're looking for. So let's go ahead and substitute 2. So if we substitute 2 on the distance formula, we're gonna get d when we substitute 2, right? When x is equals to 2. When you substitute 2, we're gonna get d is equals to the square root of what? The square root of x squared minus 2 squared plus x minus 10 squared, right? So let me substitute 2 and see what I get. When I substitute 2, I'm getting a distance of 8.24 units, right? Now let me substitute 2.1. When I substitute 2.1, I'm getting 8.26 units, right? So you can see that when x is equals to 2.1, we're getting a higher value. And when I substitute x is equals to 1.9, I get a distance of 8.26 again. Now we can see that when x is equals to 2, our distance is 8.24 units, and that's the minimum distance between the point and the function. So what you can do if you want to verify this, you can take any other value of x, right, and then you substitute it in the equation for the distance and see if you get any number that is less than 8.25. We have events A, B, and C, and then we're given the probabilities and the combinations as a Venn diagram. And the first question, 10.1.1a, says that let's find y, the probability that none of the events will occur. The probability that none of the events will occur. So the probability that none of the events will occur is always equals to 1 minus the probability that at least one of the events occur, and then that is given to us on the question statement. It is said that the probability that at least one of the events will occur is 0.893. So the probability of y is just 1 minus 0.893, and that is 0.107. Now we can do B. B is saying that let's calculate the value of x, the probability that all the three events will occur. The probability that all the three events will occur. X is here. This is what we're looking for, the probability that all events will occur. We already know that the probability of at least one event occurring is 0.893. The probability that at least one event occurs is 0.893. So all these probabilities that we see here should be equals to 0.893, right? So if we do that, we're going to get 0.893 being equals to 0.05 plus 0.15 plus 0.05 plus again 0.1, 0.2, and 0.183 plus x, right? So now we're just solving for x, the probability that all three events occur. So 0.893 will be equals to, let me just add all these probabilities. I'm getting 0.733 plus x. So consequently, x should be equals to, so we're just saying 0.893 minus 0.733, which should be equals to 0.16. So now here at x, we know that we have 0.16, right? We have 0.16 at x. And then let's do 10.2. 10.1.2, I meant 10.1.2 is saying that let's determine the probability that at least two of the events will take place. The probability that at least two of the events will take place. So we need a formula for that. The probability that at least two events of A, B, and C occur. This will always be equals to the probability of A and B plus the probability of B and C plus the probability of C and A, right? Minus 2 the probability of A, B, C. Right, so we're gonna have the probability of A and B, so that will be 0.1 plus 0.16, right? So we have 0.1 plus 0.16 plus the probability of B and C. The probability of B and C will be 0.2 plus 0.16. So we have 0.2 plus 0.16 plus the probability of C and A, so that's 0.15 and 0.16, right? So we have 0.15 plus 0.16 and then minus 2 the probability of ABC, so that is minus 2 and then 0.16. You can see here that we counted 0.16 3 times and we're subtracting 0.1 twice, so that we end up counting it only once, right? So let me just put that in the calculator and I'm getting 0.61. So the probability that at least 2 of these events will take place is 0.61. Let's do 10.1.3. So 10.1.3 is saying that are events B and C independent? Justify your answer. We have solved a very similar problem in the past, right? So what we have to do now, we have to stick to the definition. What does it mean when 2 events B and C are independent, right? By definition, 2 events B and C are independent if the probability of B and C is equals to the probability of B multiplied by the probability of C, right? So let's go ahead and look for the probability of B and C. So here on our Venn diagram, the probability of B and C is this 0.2 and X, which we know fully well that X is 0.16, right? So we have 0.16 plus 0.2. Being equals to, right? So we check in to see if they're equals to each other. So what is the probability of B? The probability of B is everything in the circle of B, right? Everything in here in the circle of B is the probability of B. So that will be 0.183 plus 0.1 plus 0.2 plus 0.16 multiplied by the probability of C. The probability of C will be 0.05. Everything in this circle here for C, right? Everything in this circle. 0.05 plus 0.15 plus 0.16 plus 0.2, right? So 0.16 plus 0.2, that will be 0.36, and it will be equals to that is 0.36008, and we can see that 0.36 is approximately 0.36008, right? So we can conclude and say that events B and C are independent of each other because they satisfy this definition here.
A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. And then the first question, how many possible 4-digit combinations are there to open the lock? How many possible 4-digit combinations are there to open the lock? So let's look at the restrictions we have. We have digits from 2 to 9 because 0 and 1 cannot be used. So we have 2, 3, 4, 5, 6, 7, 8, 9. How many digits? This is 1, 2, 3, 4, 5, 6, 7, 8. The other condition that we have is that the code must be even numbered. What does that imply? If the last digit on the code is even, then the code itself is even numbered. So we need an even number to occupy the last spot. How many even numbers do we have? Well, 2 is even, 4 is even, 6 is even, and 8 is even. So we have 4 possible digits that can occupy the last spot. So we are choosing from 4. So out of the 8 digits that we have used 1 on the last spot. Now we are left with 7 and no further conditions. So we have 7 possible digits that can occupy the first spot. 6, 5. We have 840 possible 4-digit combinations. Let's look at 10.2.82. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is true. The code is greater than 5,000 and the third digit is true. Let's make sense of that. If the code is greater than 5,000, then on the first position, we need 5, 6, 7, 8, or 9. We need 1 between those 5 numbers. We say in only 5, 6, 7, 8, and 9 should occupy that first spot. Now let's look at the other condition that we have. We must have 2 on the third spot. So here we have only 1 digit that can occupy that spot. We have 2 there. And then on the last spot, for our combination to be even numbered, the last spot must be occupied by an even digit. We need 2 to be on the third spot, so we cannot include it anymore. So we are only left with 4, 6, 8. If you saw the last video I did on probability, you will realize that we have a conflict of interest now. 6 and 8 can occupy both the first and the last spot. So we need to make calculations for when 5, 7, and 9 occupies the first spot and when 6 and 8 occupy the first spot. So let's go ahead and do that. We only do that when we have a conflict of interest like we do right now. So let's have 1, 2, 3, 4. If 5, 7, and 9 occupy the first spot, then we are choosing one of the three. And then on the last spot, we are still going to have 3 digits. On the third spot, we have 1 digit that can occupy there, which is 2. And then on the second spot, of the 8 digits, we have used 1, 2, 3. So we are left with 5. This is when 5, 7, and 9 can possibly occupy the first spot. Let's look at the case when 6 and 8 occupy the first spot. When 6 and 8 occupy the first spot, we have 2 possible digits that can occupy the first spot. On the second spot, we're going to have 5 digits after we have satisfied everything else. On the third spot, we need 2, so that is 1 digit. If 6 or 8 occupies the first spot, then on the last spot, we are only going to be left with 2 even digits. Let's say 6 occupied the first spot, then we are left with 4 and 8. If 8 occupies the first spot, we are left with 4 and 6. So we have 2 possible digits that can occupy that last spot. Now it is just a matter of putting that in your calculator and you should get 65. So the probability will be equals to 65 divided by the sample space, our total possible combinations, which is 840, which will give you 0.08.